Welcome back to P3. Today we're looking at fixed point iteration. Now this is a method to find the value of x for when f of x equals 0. And usually we need to manipulate an algebraic function first so that we're able to do this. Now some iterations will converge straight to the root, while others may go either side of the root until it eventually hits the root. Okay, and either one of those is what we would like to happen. And then there is a third case where it might diverge, so it might actually move away from the root. And those are the ones we don't particularly want because that doesn't give us an answer. Now, if I start with this function, and then I make it equal to 0, so f of x is 0, and then I rearrange it to make it x equals. So for example, I can add x and add 1, and then take the square root, and I end up with this. Then what we like to do is add in n plus 1 and n underneath here. Okay, and that's just going to stand for each of the values that I start with. So I have a starting value, and then from there I put my answer back in and my answer back in until I get to the root. Okay, so I get like a value which we call x0, which would be my starting value. Now, if I think of a rough sketch, so looking at this right hand side, root x plus 1, I get a graph that gives me this kind of curve. And then if I look at the left hand side, which would be y equals x, that's going to be a straight line. And the root is where these two graphs meet. Now, what happens in this kind of case is that I'd substitute a value of x0n, say here, and that gives me a value on the curve where I substitute it in, and then I take that answer, and that is now my x1. So this becomes my x1 value, and when I substitute that in, I get a point on the curve, and my answer becomes my x2 value. And slowly but surely I get closer and closer to this root. Now, don't worry if this bit doesn't make that much sense. It's a lot easier when you start doing it in the actual problems, and I will show you. Okay, but this is one way, and if I took this function and rearranged it in a different way around, for example, made this x equals, like x equals x squared minus 1, or I can rearrange it, I can factorize out the x and then do some rearrange it, add 1 to the other side and divide by the bracket. There's quite a few different ways in which I can rearrange this, and they all produce different results. So here are the two that I was talking about. Okay, rearranging to make x equals. And different scenarios happen. So with this one here, we actually get a scenario where we get values that go either side of the root, slowly getting closer. So we might have a first value here, second value here, third, fourth, fifth, sixth, and slowly getting closer until we hit the root. Whereas this one, we actually get a diverging sequence where we actually start and we actually move away from the root, so we never actually hit it. So there are lots of options with this, and sometimes you have to be a little bit careful, but anyway, what we'll do is we'll get straight into a problem now, and then I'll show you how to use your calculator for this problem, because it is important when you set your calculator up to make this as easy as possible. Okay, here we've got f of x equals x squared minus 6x plus 2. And our first step here is just the rearranging. So we've got x squared minus 6x plus 2, and we need to rearrange it to show each of these options. and obviously equals 0 for the f of x. So x squared plus 2 over 6, that should be quite straightforward. X squared plus 2, we take the 6x to the other side, divide by 6, and there we have it. The second one, square root 6x minus 2, so that means that we need the x squared on its own. So 6x minus 2, we would take the other side and then square root it. And then the third one is a bit like this first one, second one here, x squared, we take the 6x minus 2 to the other side, then we divide by x. Now, obviously we knew which of these three that we wanted to show here, and sometimes that's the case, or sometimes you have to just do it yourself and do a rearrangement and pick one to use. Okay, now for part B, you can see I'm just starting to make a little bit of space here, but part B we're going to start with x0 equals 4 in each iteration, and then we're going to find the root of f of x equals 0. So I'm just going to make a little bit more space again. There we are, that's better. And as you can see, I've added in an n plus 1 and an n into my formula now. Okay, because once I've created this iteration formula, then that's what I do to turn it into the iteration formula. So first step for me to do is to substitute x0 equals 4n. So when n is 0, we've got 0 plus 1 here. We're looking at x of 0 squared plus 2 over 6. Okay, that's what we're doing. I won't write this down every time, just this first one. So x1 is equal to 4 squared plus 2 over 6. So x1 equals 3. And I'm going to put that just up the top here. Next step then is to do it again. And actually I will do it this one time. So I'm putting 1 in this time, so x1 squared plus 2 over 6. So x2 is 3 squared plus 2 over 6. And we get 1.83 where the 3 is recurring. And then I'd substitute this in again to get my next value. And then my next value, and so on. And I keep repeating this process until I get it down to what I wanted. So in this case it was 3 decimal places. So I need to get it to a point where these first 3 values are fixed, they're locked in place. Okay, now as you can see, doing this step by step is obviously going to take some time. But luckily there is an easier way of doing it, which I'm going to show you now. So first what we do is we put our value in, so in this case it's 4, press equals, so it is in the calculator. Then what I want to do is where the x value is, I want to use answer. So I'm going to put, like fraction, it's going to be answer squared plus 2, and that's going to be over 6. And then I'm going to press equals. You see my first answer is 3, which is my x1. Press equals again, and we get a 1.833 recurring. Press equals again, and I get my 0.8935. Equals again, you can see I get my 0.4663. That's the fourth one. Fifth value, 6th value, 7th value, 8th value. You can see that the 0.354 is now fixed in place. Obviously I can keep going, but there's no need. Okay, and that's how I get to the answer of these kind of problems really quickly. Okay, hopefully that was easy enough to understand. I've written the values down here, and you can see the 7th and 8th value here, where I've got 0.354 and 0.354. In both of these consecutive cases, my answer rounds to 0.354, and that's where I can stop. So my X value is 0.354, correct to 3 decimal places. But it needs to be 2 in a row, so 2 consecutively, and they have to round to the same value. Okay, so obviously, had I had a value here that was like a 5 or a 6, then this would have rounded up to 5, so it wouldn't have matched up, just for example. Now I'm just going to go back to what was in the calculator just to make sure that you saw okay. I first start off with my x0 value, which is 4, so I press 4 in the calculator equals. That stores it into the calculator. Then I can use answer in replace of my x, so it'd be answer plus my 2. I've just set it up over my 6, and obviously you set it up with the fraction button. So there we are, now doing with part 2. So again, now substituting my x0 equals 4 into this. So remember, you put 4 and then equals, and then of course you set it up as you see it. So square root button, 6, answer for x minus 2. Then each time we press equals, we get the next value. Okay, it's important to do this because what's happening is once we get our answer, because we're using the answer button, it puts that answer back in the equation. So constantly putting it back into the formula, I should say, is a better word, but it's constantly putting it back into my formula for this xn for each subsequent value. Just enables me to get the answers very, very quickly. So in this one, I've got x1 is 4.6904. I don't need to write too many values here. x2, you can see how quickly it is now as I've got it set up. x3, and some might be asking me, do you need to write down all of these values? And the truthful answer is no, you don't need to write down every value. You do need quite a few values. They will be looking for quite a few values, but you know, there will be a point where if you've done quite a few, then you can skip some of your values until you get to the required kind of answer or degree of accuracy. Okay. And there you can see I'm up to 16 values there. But there is one thing I wanted to draw attention to, because earlier I said you need to look at 2 consecutive numbers that round to be the same, which I do have a little bit earlier on here. But actually, I think when you do get this, you should always check a little bit ahead. So press a few more equals in your calculator. And once I did that, I noticed that I actually did jump up again here, so I actually rounded to 5.646. Okay, and what kind of happens is the more times you press equal, the more values that kind of get locked in place. So you know, you can see here that we had different values. 4.6 here, 5 was locked in place. Then we went up here to 6, and then 6 was locked in place all the way, you can see. As we went down here, then we got 4 locked in place. Okay, as we carried on going, 5 then got locked in place. So keeping on going, we can see then that this value then actually becomes greater than 5. And if I jump ahead, this is the 25th one. I'm just going to pop up here, 5.6457. Okay, and in this case the 7 is locked in place, so 5.646 would be the answer to 3 decimal places. So just taking back what I said earlier, 2 consecutive ones should normally be enough, but there are cases where it doesn't work. So the easiest way to do is just look ahead by pressing a few more equals and just see what number gets locked in place after that value. Essentially, probably a better way of approaching this is once you get 4 values locked in place, then you know 100% what the answer is to 3 decimal places. Now, I'm not going to do this third part here, okay, but what I can tell you is the answer is the same as this one. So the first one, rearrangement, gave us one root. The second one gave us a different root, and the third one gives us the same root as the second one. And it's an x squared function, so I would expect a maximum of 2 roots. And then the final part of this question is to use the quadratic formula to find the roots of this equation. So you can see that a is 1, b is -6, and c is 2. And remember, you should know the quadratic formula off by heart now. You should have used it so much that it should be ingrained in your brain. But just simply using it, so -6 plus or minus -6 squared, and that's 4 times 1 times 2 all over 2a. Okay, and then I should get my 2 values out, which are 3 plus root 7, which as a decimal is 5.64575 and so on, which we can see is 5.646 to 3 decimal places. And then my second answer is 3 minus root 7, which is 0.354248 and so on. It carries on, which you can see is 0.354 correct to 3 decimal places. So just like what we got through the iteration formula. Now I'll give you a few to try. So in this one, we know we want the cube root. So the first thing we want to do when we rearrange this is make sure we have our cube equals. So I've got x to the power 4 minus 6 equals 3x cubed. Divide by 3, so x to the power 4 minus 6. Now I want to divide by 3, but I'm going to do it separately because I've got a separate p and a q. And then taking the cube root, we get 1/3 x to the 4 minus 2. So x equals and that means that p is 1/3, q is -2. So just remember to set your calculator up, put 0 equals, then you can clear it, and then you want cube root 1/3 answer to the power 4 minus 2. And then you get your values. You want these to 3 decimal places. So we got 2.599, so minus 1.260. x2 then, if I press equals, I get minus 1.0507, which to 3 decimal places is 0.51. And then finally, press equals again, you get minus 1.1680. These ones I can put some dashed dots afterwards to show that they are continuing. So minus 1.168. So these are my 3 answers to 3 decimal places. Now we need to choose a suitable interval. Now you need to do this with an interval. Just thinking back now where I've seen these common mistakes, the number of times I've seen them, students substitute this into the iteration formula rather than picking a suitable interval and substituting it into your f of x. So looking at this, I want to go either side. So I might look at 1.13 and now 15 and minus 1.1325. These are the two values of x that I want to substitute in. So substituting these into my f of x. Now we have to save you a bit of time. We can see here we've got a change in sign. Therefore, at least one root will lie between these two. So I want to write that down. And that's it. All done. Thanks for watching the final video in this P3 course. The next set of videos will focus on past papers, past paper questions and other specific questions that tend to throw students off in the P3 exam.